So, a couple people have asked about gears for some different applications, and I wanted to just show you around the library, the parts library that Inventor has for you. So, there's several different types of gears, worm gears, bevel gears. I'll show you a spur gear that they have. They also have cams, belts, bearings, shafts. They have pre-built parts that you can use. And where these are located, now gears, you're going to be assembling these guys together. So what you're going to do is you're going to open up a new assembly file. That's what I'm in right now. It's an IAM. And the gears are located in the design tab of that assembly file. Okay, so let's go ahead and get started. I'm going to go ahead and click a spur gear. So you could do timing gears, you could do a gearbox with this. There's actually a lot that goes into gears of how the force is coming into play and what the gear ratio is to get the mechanical advantage you want. The gear ratio tells you the mechanical advantage. So you have a small gear that's going to be spinning like mad, a large gear that's going slow, and what you lose in speed, you gain in force. So you can think of your bike gears and how those work. So if you're pedaling like mad, but you're not going very fast. So you have a small force and you're going a slow speed, and it's a balance of speed versus power on these things. Okay, so I'm going to go ahead and set this to a gear ratio of 2, which will give us a mechanical advantage of 2. And I'm doing that by just setting the number of teeth. The ratio of teeth is your mechanical advantage. So if you have twice as many teeth on one than the other, and you can think of these things, if they're not slipping, when this thing has gone around an entire revolution, it's clipped through 23 teeth. This one has gone through just half of a revolution. It's clipped on half of that number of teeth. I guess this should be 46 instead of 47. It's odd versus even. Let's try it out. So create these things in pairs, matching pairs. To assemble them, you're going to want to assemble these one at a time. So I'm going to set one of these gears to no model and the second gear to component. So I'll create this one first. And it's just like setting any other part down. And then I'm going to go ahead and click on that gears again. It's going to bring back the same things that I had before. So I'll go ahead and change gear 2 to no bottle and gear 1 to component. So this time around, it's going to be creating my smaller gear. Go ahead and say, okay, there's my smaller gear. And then the next fun part of this, of course, comes with constraining these things. So these gears are over here. They've got their own XYZ coordinates. They have their own origins and everything. So I like to go ahead and constrain them using the assembly coordinate system. Let me go ahead and turn this, make this visible. So we'll go ahead and turn on our degrees of freedom, starting out with both of the gears free to move in all directions. And let's go ahead and start by lining these guys up. So, and hopefully you've done a bit of the assembly on the other parts, so you're getting used to assembling things together. So I'll get through this kind of as quick as I can remember. So just popping both of the backs onto the same plane. Make sure they are on the same plane. If it ends up on the other side, just click this little guy. Okay, let me go ahead and turn on the visibility of this XY plane. And what I want to do is I want to line up the centers on the same plane, and then I want to line up the distance between these two guys. So I'm going to go ahead and constrain the Z-axis of this second gear to this plane. Let me just move it around. Okay, so now their centers are lined up with one another. The next thing I'm going to do is use an offset, and I don't remember the distance between these guys, so I'm going to pull up my Spur Gear again and see if I can get my, okay, so my center distance in this case is 10 inches. That's what I'll use for my offset. So I'll go ahead back to the assembly, and I'm going to constrain the center of this guy to the center of the other gear with an offset of 10 inches. And zoom in on this, see how these teeth are kind of coming together. You might have to bump it away just a little bit more, but that looks like that's going to give us a good, and well, that's a little bit of overlap, but you can mess around. To mess around with that center to center distance, you can come over here to the left-hand side, just right click on it, and like maybe I want to bump that just a little bit larger, so I'll make it 10.1 just to make sure that those really are not overlapping on here. Okay, now the really neat part, you can constrain their motion so they rotate with each other. So they go opposite directions. Make sure you get the opposite directions. The gear ratio, so we had that kind of weird 47 to 23. Notice I'm putting the large gear first, and I'm going to select the large gear first. So there's my gear ratio, and I'm going to grab kind of inside of this large gear, and then I'm going to grab inside of this small gear for my selections 1 and 2. So let's go ahead and apply that and try it out, see if they're rotating together correctly. And those teeth are not quite lining up as you're rotating them around. You can always right click on this gear ratio and suppress it, and then get back in here and make sure your teeth are coming together correctly. You can also change the gear ratio. So again, pull up under the design mode what you had in there. Let me pull that up again. So here's this says 2, but 23 and 47, that's not actually a ratio of 2. It's close, but that should be 46 instead of 47. So I'm going to go off of the 47 divided by 23 for this, and then turn on that motion. You should be able to get these guys to actually turn with one another. And then you can do that same like driven gear system. So anyways, pretty neat. Because you can poke around a little bit inside of this tool. So, the preview button, here we go. So preview, and you can really zoom in to see how those teeth are coming together, how the force is going to be transmitted through it. And you can put a helix angle on the things if you want, what that would look like. Now, if you look at the edge of it, do you see that angle on there? So anyways, yeah, play around with these. You can do worm gears. You can do the internal gears. So you could make like one of those planetary systems. There's the internal. So for that case, you have kind of an outer gear and then an inner gear that comes onto the inside of it. So yeah, lots of fun stuff to play around with on there. Very nice that this makes the gears for you, because these are quite involved to line up the teeth and get the angles right. And there's a lot that goes into gears.